Hello there, Gregory Carlson here, and let's wrap up 1.7. Here we have 49x minus x to the third is bigger than or equal to 0. Where is that true? And so let's take a step back for a second. If this was an equal sign, then this equation would have three answers because we have x to the 3 and the degree is 3. So those are going to be our critical values. So let's go ahead and find them. First, notice that you can factor off an x. If I factored off that x, I would get 49 minus x squared. So what you should notice now is that this is a difference of squares right here, and you should know how to factor those. And so if you don't know, then we will practice in class. But the way you factor it is you take the square root of both of these. So this would be 7 minus x and 7 plus x. And if you FOILed those two together, you would get 49 minus x squared. So that means our critical values are 0 because of that, 7, and this last piece gives us a critical value of -7. And so those are the three places where we equal 0. And so that means we're kind of divided into 4 regions. And let me show you where those 4 regions are. The first one is everything smaller than -7. The second region is between these two. The third region would be between 0 and 7, and the fourth region would be over bigger than 7. So here are the 4 regions, and we need to test each one. And we need to test one point in each of these 4 regions, and we're looking to see if we're positive, if we're bigger than 0. If we are, that region is part of our answer. If not, it's not part of our answer. So let's pick a point in each of these regions. I'm going to pick -10 for this region. Let's pick -1. Don't pick 0 because that's a critical value. Let's pick 2 and 8. So those will be the 4 points, one from each region. And when I say test them, I mean just plug them back into the original equation. So -10, plug that in, and we get -490. -10 times itself 3 times is -1,000. So I have -1,000, which is +1,000. So again, I have minus x to the third. 3 negatives are negative, so that's -1,000 minus -1,000 is +1,000. And we see that this will obviously equal 510, which is bigger than 0. So that means region 1 is part of our answer. Every number in region 1 is going to be positive. Let's check region 2. Let's plug in a -1. I get -49. And if I plug in -1 there, times itself 3 times is -1. So minus that would be +1. And we see that that's going to be -48. So that's a negative. So that means region 2 is not part of the answer. Region 1 was positive, so it was. Let's plug in 2. 49 times 2, I think, is 98, but let's just check to be sure. So we get 98 minus 2 times 2 times 2, which is 8. And that is 90, which is indeed bigger than 0, so region 3 is part of our answer because it's positive. 90 is bigger than 0. And let's test 8 by plugging it in. It's 49 times 8. I know this takes a while. Minus 8 to the third. So 49 times 8 equals 392. Let's see, 8 times 8 times 8. Let's write that down. 392. 8 times 8 times 8 is 512. So 392 minus 512. Is that bigger than or equal to 0? No, that's going to be a negative number. 319 minus 512, -193. So that's not true, so region 4 is not part of our answer. So that means our answers live in region 1 and region 3. So the answers are going to be -infinity to -7. Let's see if we include -7. We have an equal sign there, so yes, we will. We'll put a bracket around that. Our answers are also going to be from 0 to 7. So we write the OR symbol, brackets, 0 to 7, and you're done. That is the solution set. That is where this equation is bigger than or equal to 0. And by the way, let me show you something. If you put in a y here instead of a 0, instead of just having this one-dimensional line, it turns it into a full graph. And I actually have the graph here that I put into Wolfram Alpha. And here's where the graph is. And you'll notice that if we're at -7 right here, and to the left, we're positive. Then we're negative for a while. Then between 0 and 7, we're positive again. And then after 7, we're negative again. So do you see how it goes positive, negative, positive, negative? Look, positive. You can see positive, negative, positive, negative. It matches what we have in the graph. So that's what we're doing. And thanks to calculus, if we just find one point that's negative, it means all of these points are negative in between here and here. Or if you find one point that's positive, it's all the way positive forever and ever. So this graph and this problem have to do with each other, but you just need to know how to find these answers in order to get the homework right. Okay, very good. Let's shrink my calculator. And let's go back to this last problem, which is x to the third minus 16x is less than 0. So if I factor off the x again, I get x squared minus 16. So x times x squared minus 16 is less than 0. Factor of squares here. Difference of squares, I mean. So there we go. X times x minus 4 times x plus 4. Our critical values are 0, 4, and -4. So if we draw our little number line, we have a critical value at 0, at 4, and at -4, which gives us 4 regions. This is exactly the same process as the previous two problems. I didn't draw these in the previous two, but if that helps you, then you should use these. And so let's pick a point to test in each region. Don't pick like -1 trillion unless you just want to do that. But you can pick values that are simple. So let's pick -5 for region 1. Now I need a point between -4 and 0. So let's pick -1. Let's pick 2 and pick 10. So again, you can pick any 4 numbers you want as long as they fit inside each of these 4 regions. But I like to keep them relatively small so that life's not too difficult for us. Let's test -5. -5 times itself 3 times is -125. 5 times 16 is 80, so that'll be plus 80. -125 plus 80 is going to be a negative number, so certainly that is less than 0. So region 1 is part of our answer. Let's test region 2. Let's plug in -1. -1 times itself 3 times is -1. -1 times -16 is plus 16. And that will not be less than 0 because that equals 15. So we can eliminate region 2. We were negative here in region 1, but we were positive in region 2. So that was bad. Remember, seeing if we're less than 0, it's the opposite of this problem because we were greater than or equal to. Now we're less than, so we want to be negative. Let's try plugging in 2. 2 times 2 times 2 is 8, minus 2 times 16 is 32. Is that less than 0? 8 minus 32 is negative, so you bet that is going to be less than 0. So region 3 is good because that's negative. And let's plug in a 10. 10 times 10 times 10 is 1,000 minus 160. That is going to be a positive number, so region 4 is out. So that means our answers are, this is true in region 1 and region 3, and there's no equal sign here, so that means we're going to use parentheses. -infinity to -4, parenthesis, or 0 to -4. And that's the answer. And so we see that that's the way it's going to work. And I can just guess that this graph, I don't have this one graphed like I did the other one, but I'm guessing it's going to look, sorry, that should be a positive 4 right there. I'm guessing it's going to look something like this because it's a positive x to the third. It's going to come up like this. Cross at -4, come down and up like this. And so you see that we're negative in this branch and we're negative in this interval if we were to replace that with a y and graph the equation. So that's where we get these two intervals from. -8 to negative infinity to -4 is this branch, and 0 to 4 is this one. Now you'll notice that in both of these they alternated. That is common. That is pretty common for them to alternate, but you shouldn't assume that they're going to do that. Because, for example, check out this graph. Let's say we were doing this one. In this one, we would only have one negative branch, and then a positive branch, and then another positive branch. So just because it bounced off the x-axis. So don't assume that these are always going to alternate. Yes, no, yes, no, yes, no, yes, no. It might alternate in the other way, or you might even have two regions that are both positive. You need to test one value and test it in each region, and if that value works based on what your equation is telling you, then you know that all the points in that region are going to work. These 4 problems on this page are probably the hardest in all of Chapter 1, so make sure you practice them until you get the hang of it. If you have a question, please leave it in the comments and I will be happy to answer it. And other than that, if you like this video, please like and subscribe, and I will see you in the final section of Chapter 1, which is section 1.8. So I hope you're as excited as I am about it. See you there.